the antecubital vein, the brachial vein, and the axillary vein. Here's the axillary artery, the brachial artery, the profunda brachii artery. At the elbow, the radial artery and the ulnar artery. Now the nerves. Here's the musculocutaneous nerve, the median nerve, the ulnar nerve, and the radial nerve, with its superficial branch and its deep branch. That brings us to the end of this section. In the next section, we'll move on to look at what the upper extremity is all about, the hand. To understand the hand, we'll begin by looking at the bones and joints. Then we'll look at some important pulleys, and then we'll see the muscles. After that, we'll add the vessels and nerves, and lastly, we'll look at the skin. The terms that we'll use for orientation are ulnar and radial for the sides of the hand, radial being the side with the thumb, and palmar and dorsal for the front and the back. To begin looking at the bones and joints of the hand, let's see what they're called. Here are the 8 carpal bones, and here are the 5 metacarpals. Each finger has a proximal phalanx, a middle phalanx, and a distal phalanx. The thumb just has 2 phalanges, a proximal phalanx and a distal phalanx. The joints of the hand have long names. The joints between the carpus and the metacarpals are the carpo-metacarpal joints. The joints between the metacarpals and the proximal phalanges are the metacarpophalangeal joints. The joints between the phalanges are the interphalangeal joints, proximal and distal. We'll often refer to these joints as CMC joints, MP joints, and IP joints for short. To look in some detail at the bones and joints of the hand, we'll look first at the carpus, then at the 4 fingers with their metacarpals, then at the thumb with its metacarpal. We saw the individual names of the carpal bones in the previous section. Let's look at their overall shape. There are 2 bony projections on each side. On the ulnar side, the pisiform bone, and this part of the hamate, called the hook. On the radial side, the tubercle of the scaphoid, and the crest of the trapezium. With these projections, the bones of the carpus form the base and the side walls of a space called the carpal tunnel. Here's how the carpus looks in the living body. The radiocarpal and midcarpal joints are hidden by the heavy capsular ligaments. Here are those 4 projections again: the tubercle of the scaphoid, the crest of the trapezium, the pisiform, and the hook of the hamate. And here's the carpal tunnel, still without its roof. Now let's move on to look at the metacarpals of the 4 fingers and at their CMC joints. Here are the carpo-metacarpal joints. The bases of the 4 finger metacarpals, tightly packed together, articulate here with the distal row of carpal bones. The base of the first metacarpal, the one for the thumb, articulates separately here with the trapezium. These 4 carpo-metacarpal joints only allow a small amount of movement. The 5th metacarpal is the most mobile, the 4th is less so, the 3rd hardly moves at all, and neither does the 2nd. When the CMC joints are flexed, the metacarpal heads lie in a curve. This strong ligament is the deep transverse metacarpal ligament. It keeps the metacarpal heads of the 4 fingers from spreading apart. As it crosses each MP joint, the ligament is continuous with a structure that we'll meet shortly, the palmar plate. Since it doesn't connect to the first metacarpal, the ligament doesn't prevent movement of the thumb away from the hand. Next, we'll move on to the bones and joints of the fingers themselves. The proximal and middle phalanges are flattened on their flexor aspects. The flexor tendons run along here. The sheath that surrounds the flexor tendons is attached to these ridges. The tip of the distal phalanx is flattened. The fibrous pulp of the fingertip is attached here. The bed of the fingernail is attached here. Now let's look at the metacarpophalangeal joint, the MP joint. It's the joint at which the finger becomes separate from the hand. We'll take the other fingers away so that we can see it from all sides. The articular surface of the metacarpal head is curved in two planes, from side to side and from front to back. The base of the proximal phalanx has a concave articular surface that's also curved in two planes. The shape of the bones allows a wide range of flexion and extension at the MP joints. It also allows a range of side-to-side movement that's greater when the joints are extended, less when they're flexed. We'll see why that is in a minute. Let's see what the joint looks like in the living body. The MP joint has a capsule that's loose on the back to allow the joint to flex. On the front, the capsule thickens remarkably into a tough piece of fibrocartilage, the palmar plate, also called the palmar ligament. The palmar plate moves along with the proximal phalanx when the joint flexes. Here's the palmar plate incised to show how thick it is. As we'll see, some important structures are attached to the palmar plate, or merge with it. One of them we've seen already, the deep transverse metacarpal ligament. It goes here. Here, we've removed most of the joint capsule so that we can see the two massive collateral ligaments which hold the MP joint together. The collateral ligaments run obliquely from the back of the metacarpal head to the front of the base of the proximal phalanx. The collateral ligaments are loose when the joint is extended,